Hello guys, so in this video we are going to learn about converting a verbal description of a physical situation involving uniform acceleration in one dimension into a mathematical description. So basically, we are just going to describe mathematically all the description in physical situations. Okay, so this is a one topic in general physics 1, and if you are a STEM student, this is for you. Okay, so let's start by reading the learning objectives for this lesson. So at the end of the lesson, you should be able to define position, distance, displacement, speed, velocity, acceleration, and describe displacement, speed, velocity, acceleration mathematically. So, we use mathematics uh, in this lesson, so you have to at least prepare your learning materials in order for you to take down notes for the important formulas that we are going to encounter throughout this lesson. So let's begin. So how will you describe the motion of an object? Okay, so how will you describe the motion of these two cars? Okay, now in describing the motion of an object can be described by its position, displacement, distance, speed, velocity, and acceleration. So these terms are all connected to each other in order for you to describe the motion of an object. So when we say position, it is in the value of x, okay? It's in x as its symbol, so it describes where a particle is from the reference point at any particular time. Okay? So in order for us to identify the position, we need to identify the frame of reference. Okay? So the frame of reference or the reference point. Okay? So in this illustration, we can see that the lamppost is the point of reference. Okay? That the boy is moving away from that of the post. So we can associate time by the motion of the we can associate time or we can integrate time in the movement of the boy away from that of the post. So basically, the boy is 1 meter away from the right post of the lamp. Okay? So the post lamp serve as the reference point to describe the position of the boy. Okay? So in this video, uh, the distance, okay, in meter, okay, the distance in meter of the position of the boy is 1 meter away from the post. So take note that position is in the value of, or it symbolizes letter x. Okay, so let's continue. So the position of the boy at different times, okay? So this in this illustration, you can see the position of the boy in different times. So in this lesson, we use the positive sign to indicate the rightward direction and the negative sign for the leftward direction. So as you can see in this mathematical description, x parenthesis t describes the position and time of the boy. Now, we are going to integrate distance with this. Okay? When we the mathematical description for x0 is equal to 1 is the boy is initially 1 meter from the right of the post. So basically, 0 hindi pa siya nakakaalis dun sa or hindi pa the boy is 1 meter from the post and the boy is 1 meter from the post rather at 0 second. Okay, so as you can see in this video or in this illustration, uh this is 1 meter, and 1 meter is equivalent to 0 second. Now, let us see the mathematical description for the next for this. So, uh, x as the position and 5 as the time in second is equal to 2. So, ito yon. So, at 2 meter, naka, naka-move yung boy within 5 seconds going to the right. Okay? So, then, paano naman ito? X 15 seconds is equal to negative 1. So, the boy is already 1 meter away from the left of the post by 15 seconds. So, bumalik siya. Okay, bakit 15 seconds? Kasi, nung pumunta siya doon, okay, pumunta siya doon, yung kapag nag-move yung boy patungo sa rightward direction, nakapag-consume siya ng 5 seconds. Now, nung bumalik siya at nakapaglakad siya ng 5 meter, then nakakonsume siya ng 15 seconds. Okay? So, the distance, the distance is basically another part in describing the motion of an object. So, distance is a scalar quantity that describes the length of the actual path traveled at a given time. So, let us see in this illustration. The figure 3 presents the distance traveled by the boy. So, our lamppost is our initial position, right? Or the starting position. So, within 5 seconds, nakapag travel siya ng 1 meter. Then, within an plus 3 meters going towards that direction from the going to the left path, okay? So, that motion or kung saan lang siya naglakad, i-add natin lahat-lahat nun in order for us to get the total distance traveled by the boy. Now, take note that S is the symbol for distance. So, what is the symbol for position again? So, the symbol for position is letter X, okay? So, in order for us to identify the total distance traveled by the boy, we need to have this formula. So, S or the total distance is equal to the distance, the position 1, or the distance 1, the distance 2, and distance 3. The 1, 12, and 3 only indicates the position of the object or the boy, okay? So 1 meter plus 3 meter plus 1 meter is equal to 5 meter. So that is the total distance traveled by the boy. Okay? So next is displacement. So the symbol for displacement is X. Okay? Uh, the, the change. Okay, kapag nakakakita kayo ng triangle na ganun, it is the change or of the position. Okay? X kasi is our position. So, the change of the position or the displacement is the vector quantity that describes the difference between the final and the initial position of the particle. So, displacement as this symbol is equal to the final position minus the initial position. Okay? So again, displacement is the vector quantity that describes the difference. Okay, kapag sinabi nating difference, it is in the form of subtraction. So of the final and the initial position of the particle. So displacement is x sub f minus x sub I. Okay? So, let's proceed. So, in this illustration, the final position of the boy is 3 meters away to the left of his initial position. So, how did we get that? Okay? So the initial position of the boy is 1 meter. Okay? So, the initial position dito is 1 meter going towards that direction with respect to 5 seconds as its time. Now, nag-move siya towards that, ang final position niya is 2 meter. Okay? 2 meters with 20 seconds as its time. Okay? So, basically, 2 meters negative 2 meters or the 2 meters minus 1 meter is equal to 3 meter. Okay? So the final displacement of the boy is 3 meter. Okay? And again, negative signs indicates the path or the movement of the boy going to the left part of the uh, left part, okay, with respect to its position. Okay, now let's continue. What is a speed? So, a speed is a scalar quantity which tells the distance traveled within a given time interval. So, basically, pagsasamahin natin yung distance at saka yung time. So, ang speed, we can, alam na natin ang speed, right? So, nakikita natin to sa mga car natin with yung speedometer, yung tinatawag nating speedometer. Now, in calculating the speed, we have the so-called average speed, okay? The average speed describes the total distance traveled within a given time interval, okay? Total distance traveled within a given time interval. So basically, the average speed is equal to the total distance divided by the total time. Now, the total distance traveled by the boy is 5 meters. Okay? Then, ang total time niya sa pag-travel sa distance ng na 5 meter is 20 seconds. Now, in order for us to get the average speed, we just have to divide the values, okay? So, 5 divided by 20 is equal to 0.25 meter per second. So how did we get the meter per second? So take note class, or take note that meter per second is a unit for the average speed. Okay? Take note of that. So let's continue. So what is velocity? So velocity is a vector quantity that describes the change in displacement with respect to change in time. So, kanina pinag-usapan natin yung change, yung association ng distance sa time, at ngayon naman pag-uusapan natin yung change ng displacement with respect to time. Okay? So, dito, in order to get the velocity, we have to see, or we should know the displacement, or the symbol for displacement and the symbol for time. Now, the average velocity is the particle describes the change in displacement within a given time interval. So now, the formula in getting the average velocity will be like that. Okay? So, the average velocity with respect to its position is equal to the displacement, okay? And displacement is equal to the difference between the final position and initial position, okay? And how about the time? So, time is the change, or the change of time is equal to the final time with respect to the initial time because we are using or we are trying to get the time interval. So in this illustration, so we have the so-called time here, okay? This is the time, and uh, the x-axis with respect to the Cartesian coordinate plane indicates or symbolizes the time, and the y-axis symbolizes the displacement. Now, let us see. So, P1, P2, P3, and P4 are our position. Now, with respect to the average velocity, this is now the average velocity between the final position and with the final position and the initial position. So basically, x or the displacement will be the x2 minus x1, and the time will be the t2 minus t1. So basically, dito yung position niya ng t1 at doon naman ang position ng at dito naman yung position ng t2. Okay, kung saan siya nakarating. Kung saan yung uh, uh, kung saang part ng coordinate system sila nag-meet. Okay? So that is velocity. Now, velocity describes the change in displacement with respect to the change of time. Now, let's see this illustration. Okay? So, the average velocity with respect to the position as symbolizes by x is equal to the change of uh, is equal to the displacement over the change of time interval. Now, we just have to substitute the values, okay? So, the average displacement would be uh, -2 meter minus 1. So, kanina nakalculate na natin yung tinatawag nating displacement. Okay, 'di ba? Ang displacement natin kanina ay ito, -3 meters. Now, punta tayo sa time. Okay? So, sa time naman is we have 20 seconds minus 0 seconds. So, meaning to say, it's 20. So, 3 divided by 20 is equal to 0.15 meter per second. So, there is the big difference between the average velocity and the average speed. Whereas, mas malaki yung values ng average speed with kasi it is just the scale it is just a scalar quantity, whereas dito kasi sa velocity it depicts the vector quantity which indicates the direction of the object. Okay, so let us continue. So the average velocity of the boy with from his position to his final position is -0.15 meter per second. Okay? So he is moving from that of the lamp post going to the left direction with the average speed of 0.15 meter per second. Okay? So next is uh we have the instantaneous velocity. So it is a part of velocity which terms as particle describes the change in displacement in the specific point of time. So kanina kasi dito sa tinatawag nating average velocity, ang pinag-usapan lamang natin doon is yung time interval. But in the instantaneous velocity, what are we going to do or what are we going to discuss is the change of displacement in the specific point, okay, point of time or point in time. So basically the instantaneous velocity with respect to the point of time is equal to the point of time from that of 0 multiplied to the change or the displacement and the change of time, or change of the position or the change of time, and it is equal to the d of dx and dt. Ano nga ba yung tinatawag nating d? So it's basically the distance of the position and the time. Okay, so now in this figure, the figure 7 presents the instantaneous velocity of the particle at P position 3. So, how did we get that? So, sa pag-travel kasi ng we have to use again the Cartesian coordinate plane in order for us to get the position of or the instantaneous velocity of a moving object. So now, x-axis symbolizes it will be our time, and the y-axis will be our displacement. So in the first position, second position, and the third position, we can see that the third position is the average or the instantaneous velocity of the moving object. Okay, so let us continue. So the motion of the particle is given by x is equal to 5 meter per second square multiplied to t square plus 1, where x is the meters and t is in seconds. What is the instantaneous velocity of the particle at 3 seconds? Okay, going back in this problem or illustration, let us read it again. So the motion of the particle in the given is given by x is equal to 5 meter per second square multiplied to time squared plus 1, where x is in meters and t is in seconds. Now, the question is, what is the instantaneous velocity of the particle at time 3 seconds? So basically, to answer this, we have to identify the given values. Okay, so x is equal to 5 t squared plus 1, and the formula in getting the average average velocity or the instantaneous velocity with respect to time is equal to dx divided by dt. Okay, with x is the displacement or the position, and t is equals to time. So first, in order for us to solve this problem, we have to compute the instantaneous velocity at any time by time t by taking the derivative of both sides. So as you can see, the given values are indicated here. Okay, then we are just gonna derive formulas to get dx is equal to 5t squared plus 1 multiplied to dt. Then you have to compute the instantaneous velocity at time per 3 seconds. So you can also use that. Then you can use this formula whereas instantaneous velocity is equal to dx divided by dt, and it is equal to 10, okay, 10t. Okay, now to get the instantaneous velocity, we just have to substitute the 3 here. Okay, so we have to substitute the seconds or the time here. Then 3 is equal to 30 meter per seconds. Okay, to continue, acceleration is the vector quantity that describes the change in velocity with respect to the change in time. Now, we have the two types of acceleration. We have the average acceleration and the instantaneous acceleration. In calculating the average acceleration, we have to describe the change of velocity with a given time interval. In the instantaneous velocity, we have to at least remember that there is a change in velocity with respect to the specificity of the time. Okay, so take note of the following formulas in order for you not to be confused with our future calculations. So basically, the average acceleration or with this formula is equal to the change of the velocity with respect to time. Okay, so the average instantaneous acceleration will be uh, the given example. Okay, the given example multiplied to the average velocity, then the average time. Okay, so this is the difference, or the figure 8 and figure 9 uh, presents the difference or the graph showing the average in instantaneous acceleration of the particle or the moving object. So now let us try to solve this problem. Okay, the motion of the particle is given by the velocity, which is equal to 50 meter per second plus 0.60 meter per cubic second multiplied to uh, time squared. Okay, where velocity is in meter per second and t is in seconds. Now, the first thing that we have to do is what is the average acceleration of the particle in the time interval t1 is equal to 1.1 second and time 2 or t2 is equal to 6 seconds. Now, the second question will be like this. What is the instantaneous velocity of the particle at t is equal to 3 seconds. Okay, let us try to solve this. So for the first part, which is the average acceleration, the given values is 50 meter per second plus 0.60 meter per cubic second multiplied to time squared. Okay, now the first thing that you have to do is to compute the velocity at uh, t1. Okay, whereas time or the first position or time will be 1 second. In order for us to do that, we just have to substitute the values from the given formula. Okay, so this is our formula, so we just have to substitute the values to get 50.60 meter per second. Now for the second one, compute the velocity of t2, whereas t2 is 6.0 second, then we just have to again substitute the value of 6 in the formula, so we can get the 71.60 meter per second. Okay, now in order for us to compute the average acceleration of these two quantities, what are we going to do is to use the formula given here below. Okay, so the average acceleration will be the average velocity, which is 71.60 meter per second minus 50.60 meter per second divided by 60 or 6, the final time minus the initial time. So now the average velocity or the acceleration rather is 4.32 meter per second square. Okay, so I think let's proceed now to number 2 as the number 2, and the question is what is the instantaneous velocity of the particle at 3 seconds. So can you at least see the difference between the average acceleration and the average velocity, whereas dun sa unang ginawa natin kanina, ang ginawa natin is yung time interval. Okay, whereas dito naman sa instantaneous velocity, we are trying to calculate the velocity of the moving object per at its position. Okay? Now, may klase pa ako. Instantaneous acceleration at t is equal to 3.0 seconds. So basically, the given values here is the instantaneous acceleration is 50 meter per second plus 0.60 meter per second cubic second uh, multiplied to the value of t squared. Okay, so now what we're going to do is to compute the instantaneous acceleration at any time by uh, t by taking the derivative of both sides. So yun nga, we just have to derive formulas from here. In order to derive the formulas, we have to cross multiply and substitute the values given there. Okay, so since 3 is our initial the position or the time, we just have to what do you call this we just have to substitute it, and then we can get this formula. Then we just have to calculate it using your calculator, and then we can get the instantaneous acceleration, which is 3.0. It is equal to 7.20 meter per seconds square. Okay, so remember that these are the physical quantities in our in discussing physics. Okay, so these are the basic formulas in order for you not to be confused for our future what they call this discussion. So we have position, distance, displacement, average speed, average velocity, instantaneous velocity, average acceleration, instantaneous acceleration. Now these are their symbols, and you have to memorize all that. And then uh, take note that in this first part, these are all scalar quantities. Okay, position, distance, displacement, and average speeds are all scalar quantities, which means it doesn't give you the direction. Okay, whereas dito, these are all vector quantities, which means it gives magnitudes and directions. Okay, that would be all, and that ends my presentation. Okay, goodbye.